Hi guys, welcome back to my channel. In this video we're going to look at Open Shortest Path First, OSPF. Okay, so in the previous videos we have covered default routing, static routing, RIP and EIGRP. Okay, and suppose guys who have not watched the videos, kindly refer back to the previous videos. I will leave a link on the description part and on the first comments so that you can access the full tutorials. Okay, and again guys, suppose you have not subscribed to our channel, kindly do us that favor, like, subscribe and comment below. Okay, and now let's start. OSPF basically stands for Open Shortest Path First. This is a dynamic and a link state routing protocol, and this is the most widely used routing protocol encountered. Okay, so it's a link state routing protocol, then it's open standard. Okay, open standard basically means it can be used with all the products, be it Cisco products, Huawei products, HP products, Juniper products, and so on and so forth. Okay, but EIGRP is Cisco proprietary, so you cannot use it in Huawei product or HP product. It's only meant for Cisco products. EIGRP. Okay, it's Cisco proprietary. OSPF and RIP, there's open standard, right? Okay, so guys, the routers running OSPF, they have to establish neighborhood or neighbor relationship before they can exchange information or routes. Okay, in the topology, when routers are running OSPF protocol, then they must establish neighborhood or neighbor relationship before they can exchange routing information. Okay, so because OSPF is a link state routing protocol, neighbors don't exchange the entire routing table. Okay, underline this one. Okay, they don't exchange the routing tables. Remember, in the case of RIP, the routers exchange the entire routing tables. Okay, as an update. Okay, but instead they exchange information about the topology. Okay, very important. They don't exchange the entire routing table. What they do is to exchange the information about the network topology. Okay, all right, so each OSPF router runs an algorithm called shortest path first. It's supposed to be SPF. Okay, not SFP. They run an algorithm called shortest path first algorithm, okay, to calculate the best routes, okay, and add those best routes to the routing table. Okay, which algorithm does OSPF protocol applies? SPF, shortest path first algorithm. Okay, so because each router knows the entire topology of the network, there is a minimal chance of routing loop to occur. Okay, the possibility of routing loops to occur in OSPF enabled network is very minimal. Okay, why? Because the routers in the entire topology, because the routers in the network knows about the entire topology of that network. Okay, so let's look at some of the various features of OSPF. Okay, the first feature is it's a classless routing protocol. Okay, then it supports variable length subnet mask, VLSM, then classless interdomain routing, CIDR, and manual route summarization, equal load balancing. Okay, some of the features OSPF supports. Okay, and again another feature, it supports incremental updates. Okay, then again it uses only one parameter as a metric, the interface cost. Guys, for the part of routing metric, various routing protocols use different metrics, different routing metrics. For the case of RIP, we said RIP uses op count as the routing metric. HSRP uses bandwidth, delay, reliability, and load as the routing metric. But for the case of OSPF, it uses the interface cost. Pretty much simple. Okay, another one, the administrative distance of OSPF by default is 110. Okay, but in the previous classes we said the administrative distance of RIP is 120. HSRP is 90, but in the case of OSPF it's 110. Okay, another important feature, OSPF uses two multicast addresses. Okay, the first one is this one, 224.0.0.5, and another one is this one, 224.0.0.6, for routing updates. Okay, so guys, it's pretty much simple, very very simple. So let's see what's next. OSPF tables. Just like in HSRP, there were three tables: neighbor table, topology table, and routing table. And in the same case, it's here. Okay, and now for the case of OSPF, neighbor table stores information about OSPF neighbors. Okay, now, and the topology table stores the topology structure of the network. It's just similar for the case of HSRP. It's similar with HSRP. Okay, and finally, routing table stores the best routes. Very simple. Neighbor tables, information about OSPF neighbors. Topology table stores the topology structure of the entire network. Then routing table stores the best routes. Okay guys, so OSPF neighbors, very important. OSPF need to establish a neighborhood or neighbor relationship before exchanging updates. Okay, in a network where there are many routers, okay, and they are connected to each other, okay, before they can exchange any routing updates, they need to establish neighbor relationship. Okay, so OSPF neighbors are dynamically discovered by sending hello packets. Okay, so for a given period of time, each router sends a hello packet in order to dynamically discover any OSPF neighbor nearby. Okay, alright, and these hello packets, they are sent to a multicast address of this one, 224.0.0.5. This address basically it's used to discover OSPF neighbors. Okay, alright, pretty much simple. As in the case of this diagram, there are two routers. Okay, this router here will need to send an hello packet through this interface in order to dynamically discover any OSPF neighbor nearby. And suppose there was an OSPF neighbor on this side, router 1 will also send a hello packet. Okay, and they will form neighbor relationship. Very simple. OSPF packets. Typically, there are 5 packets in OSPF. The first one is called the first one is called hello packet, and as we have said, hello packets are basically used to dynamically discover OSPF neighbors. Okay, each router within a given period of time, they will need to send hello packets through the interfaces in order to dynamically discover any nearby OSPF neighbor. Okay, another packet is database description, okay, which is initialized by DBD. Okay, and these packets, they describe the topological database contents. Okay, all right, mark this. They are used to describe the topological database contents, right? Okay, another packet is link state request, which is LSR. LSR, they are used for requesting the pieces of neighbor database, which are more up to date. Okay, basically link state requests, they are used to request the neighbors database, suppose they are more updated than the sending router. Okay, all right. So another one is link state update. So for the case of link state updates, they contain a list of link state advertisements that are updated. Okay, in the first case, you requested, and now it has been updated. Okay, under link state updates. Okay, and now finally link state acknowledgement. Now when you receive something, you should acknowledge. Okay, you should acknowledge. Under the final packet, you acknowledge the receipt of the update. Okay, all right. So guys, what's important here is to know the 5 types of OSPF packets and the use of each packet. And basically, you need to understand how OSPF neighbors are formed, which multicast address is used. Okay, and finally, the OSPF tables, very important. Okay, so let's see what's next. OSPF neighbor states. Guys, OSPF packets and OSPF neighbor states are the most widely asked questions in any exam. Okay, and now let's dig in the OSPF neighbor states. Okay, so OSPF routers need to go through several states before they can establish a neighbor relationship. Okay, before they can establish a neighbor relationship, the OSPF routers need to go through several stages. Okay, so the first state is called init state. In init state, let me just draw the diagram here. Let's say this one is a router and this one is also a router. Okay, and they are connected. Under init stage, a router will send an hello packet, okay, to this router. Okay, and this router here will also send an hello packet, okay, in order for them to be neighbors. Okay, that is stage 1. Init stage, a router has received an hello packet from other OSPF router. Okay, so that one was the first stage, and now the second stage, the second router will send back the hello packet. It's called two-way. Okay, two-way. Router 1 sent an hello packet to router 2. Okay, router 2 found that, oh, there is a router that we need to be neighbors, so let me just reply with hello packet. It has replied with hello packet. So the first step was in this stage. The second step is two-way state. And now exert state. Under exert state, the router starts to exchange link state information. So let's say this is stage 3. This router starts to send link state information, LSA. Okay, right? And this router also can exchange the link state information. Okay, that is stage 3. Okay, and now stage 4, exchange state. The routers now change the database descriptions. Okay, now this exchange database description with this one, and router 2 will send the database content to router 1. Very simple, guys. And exchange state. And now number 5, the loading state. One neighbor sends link state request for every network it doesn't know. Okay, the other reply with link state updates. Let's say there is let's say router 1 is sending, this is stage 5, router 1 is sending link state requests to router 2, okay, to inquire about the network it doesn't know. Okay, suppose router 2 receives that packet and it is aware of that network. Router 2 will reply, okay, with link state updates. And now finally, full state, number 6. The full state, now both routers have synchronized database and are fully adjacent with each other. Okay, meaning the information on this router 1 is equal to the routing information in router 2. Okay, alright guys, OSPF areas. Guys, area is a very important concept in OSPF, and basically OSPF uses the concept of areas. Okay, and now an area is just a logical grouping of contiguous networks and routers. How you can logically group your devices, okay, in the network. And now all routers in the same area have the same topology table, but they don't know about the routers in other areas. So let's use this diagram to describe point number 2. All the routers in area 10, they have the same topology table, but they don't know about the topology table in the routers in area 0. The same case, the routers in router 0 have the same topology tables, but they don't know the topology table of routers in area 20 and in area 10. Very simple. So the main benefit of creating areas is that the size of topology and the routing table is reduced. Okay, less time is required to run SPF algorithm, and routing updates are also reduced. Okay, for example, this router here, the routing table will only contain the updates from the routers in this network, not in this network and not in this network. Okay, so the routing table is reduced. And now guys, finally, there are two types of areas: a backbone area and a non-backbone area. A backbone area is always area 0. Okay, but non-backbone area can start from 1, 2, and so on and so forth. Okay, but you must know that backbone area is area 0, backbone. So in our case here, this is backbone area. Okay, but these one are non-backbone areas, this one and this one, non-backbone areas. Okay, pretty much simple. So let's see what's next. ABR and ASBR. area border router and autonomous system border router. Very important concept in OSPF. So guys, a router that has interfaces in more than one area. Okay, suppose a router has interfaces in more than one area. Let's say area 0 and area 1, or area 0, area 1 and area 2. That router should be called area border router. Okay, area border router. Okay, and now autonomous system border router. Autonomous system border router is that router that will connect OSPF network to other routing domains. Let's say a router that will connect OSPF network to EIGRP network. It's called autonomous system border router. Okay. We have a topology here. This one is area 0. This is a backbone area. This one is area 1, non-backbone area. And you know, they run OSPF protocol. Area 1 and area 0, they run OSPF. And there is another EIGRP network here. So for the case of area border router, router 3 matches the description because it has its interfaces connected to more than one area. Router 3 here connects area 0 and area 1. Okay, router 3 is our ABR. Okay, and now for the case of autonomous system border router, we come here where we say it connects an OSPF network to another routing domain. Let's say EIGRP network. So router 6 here, this is router 6, it connects OSPF network to EIGRP. So this is our ASBR. Okay, very simple guys, very simple. ABR, ASBR, pretty much simple. Commonly asked questions, kindly remember that. And now finally guys, let's see how we can configure OSPF. There are two ways, just like in the case of EIGRP. Okay, so we have a topology here. We have 2 routers and 3 networks. This router 1 here should advertise this network and this network, and router 2 here should advertise this network and this network. So when you go to our command line interface for configuration, these are the commands that we will include. So we come, the first command will be router OSPF, then autonomous system number, just like in the case of EIGRP. And then which networks? This one and this one, this network. And now the concept of wildcard mask, we did it in EIGRP. Suppose you have not watched that class, I will leave a link in the description part so that you can understand how to configure EIGRP. Okay, it's pretty much simple if you start from static routing, default routing, RIP, EIGRP, then to OSPF. And now the third command guys, you include the area. Okay, area 0. Okay, router 2 has 2 networks. The second configuration, advertise this network with a wildcard mask of this one and the same area 0. Okay, you come to router 2 here. Router 2 will advertise this network and this one. So the same concept guys, and they should run the same autonomous system number. Good guys, so let's go to the second way. In the second way guys, now we have 2 areas, but in the first case we had only 1 area, but now here it's a case where we have 2 areas. So we start our configuration, the same commands, router OSPF, the same autonomous system number here, and then for router 1 it advertises this network and this network with the wildcard mask of this one, then this network with the wildcard mask of this one, and the area. Okay, it is in area 0 as you can see here, area 0. Okay, And now guys, there's a new concept here that is called route ID. Okay, you include route ID. So you configure the router ID here. This is 1.1.1, and now you go to router 3 here. Let's leave this one first because this one is where complications are. Let's start with router 3. Now for the case of router 3, just the same configuration, OSPF, same autonomous system number, then you advertise the networks, and now because it is in area 1, okay, you include area 1 and the route ID. Let's say it is 3.3.3, okay. And now finally guys, router 2. So router 2, the router OSPF, the same autonomous system number, it advertises a network in area 0, okay, this network, and another network in area 1. Guys, concept pretty much simple. This network is in area 1, it advertises it. This network is in area 0, it advertises it, and you include the route ID. Guys, pretty much simple. And all this, let's see them in our practical. So guys, if you like this video, kindly subscribe, comment and share, okay? And suppose you have not subscribed, do us that favor guys, click on subscribe button, and see you again in the next class. Bye.